So we're going to take a look at the second half of the 2013 team competition for the Math Counts chapter. All right, so what is the probability that a randomly selected integer from 1 to 81 inclusive is equal to the product of two one-digit numbers? Express your number or your answer as a common fraction. Well, obviously we're going to start with the obvious, that we have 81 possibilities to choose from. And we'll just hold on to that for a little bit. Now, we also know that we can make a little multiplication table. Move that over here. And that will give us a good way of organizing what numbers we can create by multiplying two single digits together. Now, the trick here is a lot of the digits will be repeating digits. That will happen several times. Like 12 is going to show up a lot on this table. And we don't want to write every one that we, and everyone doesn't count. They're just the first one we're going to count. And I'm probably not going to go through this whole thing, because once you see the strategy, it's pretty quick. Well, we know 1 times 1 is 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we don't have any repeats because it's our first row. But this column is the same as this entire row. So right now I can safely cross those out because those would be duplicates. 2 times 2 is 4, which we already have. 2 times 3 is 6, which we already have. 2 times 4 is 8, we already have. And now we get to our new ones. Are you going to stay while you eat the cookie and then go down? I think Mommy's waiting. Okay. All right. So 3 times 2 is 6. We already have a 6. 3 times 3 is 9. We already have a 9. 12, we already have. 15 is the first one we don't have. So 15, 18, we already have. 7, that's 21, 24, and 27. And now we've already done the 2 and the 3 row, so the 2 and 3 column can just be left. They're going to be repeats. 4 times 4 is 16, which we already have. 4 times 5 is 20. We don't have that. 24 we already have. 28 we don't have, and everything above it we don't have as well. So we have 32 and 36. And we can close out this row. 5 times 5 is 25. 30, 35, 40, 45 are all new. And then we can close out the 5s. 6 times 6 is 36, which we already have right here. 6 times 7 is 42. We don't have that. 6 times 8 is 48. And 54. Close out the 6s. 7 times 7 is 49. That is new. 7 times 8 is 56. And 7 times 9 is 63. All new. Close out the 7s. I might as well finish it at this point. 8 times 8 is 64. I don't have a 64. 8 times 9 is 72. Close out the 8s, and 81. So we can count up what numbers are unique. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So we have 36 out of 81. Both these numbers share a factor of 9. So that is equal to 4/9.
Which you had up on the board.
Which is the answer.
We were doing the competition, and we failed to notice.
I know, it's funny how that works. I've done that a lot. You leave
Wait, you did that on purpose?
No, I forgot, but I've done that a lot.
Oh, you had the whole strategy up here on the board?
Mm-hmm. The whole thing was there. All right, so Shania, I guess her name is, has one stick length A and another stick that's length B, where A and cannot equal B. She needs a third stick to that is strictly between 8 and 26 centimeters to make the third side of the triangle. What is the product of A, B? All right, so what I know about triangles is that the two legs of the triangle, any two sides of the triangle, have to be larger than the third side. Otherwise,
I got it.
that's, yep, she's wondering where you are. Otherwise, it's not going to make a triangle. It's just going to be a straight line and you can't connect. So,
I know, I'm coming.
so if I have, there we go. So if I have the small stick and the long stick, end to end, that means the third stick it can't be longer than 26, right? So that means A plus B, maximum it could be is 26, right? Now, the other strategy is I could have one stick and it can essentially be on top of the other stick. And so this difference from here to here is 8. So that means A minus B would equal 8. All right, so let's add this together. We just have a system of equations in standard form. A plus A is 2A. B minus B is 0. See how that cancels out nicely? 34. So divide by 2, and you get A is equal to 17. All right, so let's plug in 17 and see what B is. So if this is 17, 17 minus something is 8. Well, 17 minus 8, sorry, 17 minus B, 17 minus 9 would be equal to 8. But that's not what they want. They want the product. So I have to multiply these two numbers together. I'll see you at Chipotle in minutes. So 17 times 9 is equal to 153. And that's it. Being able to write equations and solve a system of equations makes things really, really simple. All right. Number 8 is a logic question. I have a piece of paper that's sort of long and narrow. That's 2 by 12. And I have another paper that's a little bit wider and a little bit shorter. That's 3 by 8. And I noticed that 8 times 3 is 24, 2 times 12 is also 24, so they have the same area. And so the question is, how can I cut this paper with one cut, not necessarily straight, that can create a shape that would cover this? Well, this is kind of a tricky problem because I need to make this length 1 less and this length 4 more. So how can I do that? Oklahoma. Oh, Oklahoma. All right. I feel like I'm in the movie Dirty Rotten Scoundrels and I'm Rupert the Monkey Boy. Oklahoma. Why am I thinking about Oklahoma? Here's why. If I make Oklahoma the panhandle shape, all right? So now what I can do is this, look. And obviously, I'm not drawing this super to scale, so it's not going to be perfect. If I cut along this line, and I'm going to duplicate it, okay, just have the orange. I'm going to duplicate it, flip it upside down. So here's my paper that I've cut along this diagonal line. And all I need to do now is shift it like this. And now this length is 4. This length is 8. 4 plus 8 is 12. And I reduced it by 1. All right. So now I have a height of 2. That's my one cut. So this cut, so let's analyze how I cut this. So let's look at this cut. So this length here is 4. This length here is 1. This length here is also 4. 4 plus 1 plus 4 is 9 inches for one cut. All right, number 9. All right, so if I were to take 30 of the numbers in this pattern and line them up so that they're all stacked, I'd get the units digit with a bunch of 3s. Well, how many 3s would I have? I'd have 30 of them. So 30 times 3 is equal to 90, which means to scoot this up. I'm going to scoot this up a bit, which means the units digit for the sum would be a 0, and I'd carry the 9 over. Well, how many 3's will be in the second column? Well, only the 33, right? I guess it'd be this one, right? 3 plus 9 is 12, carry the 1. How many 3's will be in this one? Only 1, so that's 4. And so then, from here on in, I would have 3's for all of the other digits. Okay, I have 30 total digits in the last one, so that means 3 of my digits in my sum are not 3, and all the other ones are 3. So that leaves me with 27 3's. Well, 27 times 3 is 1, carry the 2, so that's 6 plus 8. And then I have 4 plus 2. 4 plus 2 is 6, so plus 6. So that gives me 87 as my sum for all of the digits. I'm sure a lot of you are looking at most of these problems and thinking, oh my goodness, it was that simple. Well, here's the last problem. And I would not say it's quite as straightforward as the other ones. Go away. All right, so I have 2 trains. One is a bullet train, and the other one is not. It's a freight train. But the freight train is longer than the bullet train. And the freight train is equal to 3 bullet trains. And so I have a situation where I have a freight train, and it is about to pass a bullet train. Okay, and I want to know, and we know that for this situation to go from here to here, takes 24 seconds. So our question is, how long will it take? How long will it take for 2 bullet trains to go from this situation? No, it doesn't look like a bullet, but whatever. To go from this situation to this situation, where they have fully passed each other. And so that's what we're going to have to figure out. Now, the other piece of this puzzle is we need to know that the rate of an object times the time is equal to the distance. So they give us the rate of the freight train. The freight train is traveling at 90 kilometers per hour. The bullet train is traveling at 210 kilometers per hour. That's really, really fast, by the way. Like really fast. So the first thing we need to do is we need to find the distance. Because in this situation, we know the rate and we know the time. We need to figure out how long this bullet train is. And once we find out how long the bullet train is, then we can transport that over into this part of the problem. So we have kilometers per hour, and then we have 24 seconds. Now, this is going to create a little bit of a problem for us, folks, because we have hours and seconds. So we need to do a little bit of conversion on this one. And I grabbed the wrong number. Hold on a second. So the most efficient thing to do is we know that in this situation, they're passing each other at a difference of what? Because they're both going both the same direction. So that means that this is going 90 kilometers an hour relative to the ground. This is going 210 kilometers relative to the ground. So that means the difference in them is going to be 120 kilometers per hour. So the bullet train relative to the freight train is going 120 kilometers an hour faster. So I want to turn that into, well, I can turn this into kilometers per second, or I can turn this into hours. And shockingly, like normally I like fractions, but in this case, I turned this into hours. So I said 24 divided by 60 minutes in an hour divided by 60 seconds in a minute. So this is my how many seconds it takes for them, or how many hours it takes for them to cross. Okay, great. So what is the distance? So we have our rate. The rate is 120. We have the speed, which is this monstrosity over here. And I multiply those together and I'll get the distance. So I'm going to multiply that by 120. Oh, so that means the total distance that they traveled is 0.8 of a kilometer. Well, the freight train is 3 times the length of the bullet train, which means this has to be 0.2 and this has to be 0.6. 0.2 times 3 is 0.6. Okay, so the length of the bullet train is 0.2. Now we can hop on over here. So that means this distance from here to here is actually 0.4 of a kilometer. And we know that they are passing at each other. Whew, they're going to be going super fast, aren't they? Okay, so the next step on this problem is, again, rate times time equals distance. And this time we're looking for the time. So the rate of their closure rate, is going to be 420 kilometers per hour because they're going at each other. I don't know the time, and the distance is 0.8. No, it's 0.4. Okay, so we have 0.4 divided by 420, all right, which is this nastiness. But this is how many hours. We need to know how many seconds. So I'm going to multiply it by 60 seconds in a minute times 60 minutes in an hour. And voila, we have our answer. And it says rounded to the nearest hundredth. This is the nearest hundredth right here. And so 8 is bigger than 5. So my final answer is 3 seconds and 3.43 seconds. Wow. Those trains are going really fast.